All right, so today we're going to work on lesson 5.4, which is really an extension of what we did yesterday in lesson 5.3. We're still continuing to improve triangles congruent, but today's technique is going to be to use angle side angle and angle angle side as our congruence properties that will allow us to show the two triangles are congruent. All right, so if we look at angle side angles congruence property, the obviously the way it's stated is what we're looking for. In two triangles, we're looking to have two angles shown to be congruent. And then the included side, which means the side between the two angles has to be congruent. And if that's the case, then, like I'm saying here in my statement, I got angle B and angle E are congruent. Angle A and angle D are shown to be congruent. And then segment BA and segment ED are congruent. So I have two angles congruent to one another and the included side between those two angles congruent. So that's enough for us to say then the triangles are congruent by angle side angle. Okay. So again, we're trying to prove triangles congruent, which means we want to show that they're exactly the same. And rather than to have to show all six corresponding parts are congruent, if we show the right three, or in this case, it's an angle, a side, and an angle, that's accepted. That's enough to say that the two triangles are congruent. So angle side angles are our next property. After that, we got angle, angle, side. So what happens here is if I can prove two angles of one triangle are congruent to two angles in the other, if I just have another side, whether it be the included side like it was last time in the first example, or just a different side, that's enough to say the two triangles are congruent. So you'll notice that it's an angle, and a side. The last one was angle side angle, so it was just the arrangement of letters. But the concept is, if I get two angles shown to be congruent, and I can show another side, then that's enough to say the triangles are congruent. All right. So in this case, I don't get the included side, but I do get a side. So I'm going to go angle, angle, side, angle, angle, side. Okay. So the difference between the two is just which side do you get? Do you get the included side or do you get a different one? Either way, the triangles are going to be congruent. All right. So that's what we're going to work on today. So we're strictly going to look at how we can solve or prove two triangles congruent using one of these two, angle side angle or angle angle side. All right, so here's our first example, and the first types of questions are just like yesterday, where you have to fill in, the missing statements that give you the proof all laid out. So it says we're supposed to prove that triangle DEF, this triangle, and triangle HGF, we're trying to prove those two are congruent. They're identical to each other. We're given EF is congruent to GF, and we're given that angle DEF is congruent to angle HGF. And we're trying to prove this. So the first thing I'm always going to tell you to do is we got to have a plan of attack. We got to be able to see what we have, what else we can prove. So I redraw it, and then I label what I know. I know EF is congruent to GF, so I know those two sides are congruent. I know angle DEF and angle HGF. So DEF, trace it DEF, that angle, and HGF, that angle. I know those two are congruent. So I know an angle and I know a side. Now I have to find out one more piece of information, and that comes from the drawing. You should be able to see that angle GFH and angle DFE, they're vertical to each other. And we know vertical angles are always congruent. So that's going to be our third fact that we need. And I'm going to have angle, side, angle, angle, side, angle. So now we go down here and fill out the proof. So segment EF is congruent to, and right there I got it, GF. That was a given. Angle DEF is congruent to angle HGF. That was a given. Angle DFE, so DFE and angle GFH, or GFH, they're congruent because they're vertical angles. Now I could have wrote HFG, that'd be the same thing. And then finally, the two triangles are congruent because of the angle side angle congruence property that we just discovered. Okay, so make the picture, see what you have, see what else you can conclude, and that should lead you to the answer. Okay, another one like that. So I got triangle ABC, this half of the triangle, if you will, and triangle ADC. I'm trying to prove those two are congruent to each other. Now, what I'm told is angle ACB, so ACB, that angle is a right angle. ACD, I'm told that's a right angle. And I'm also told that angle BAC and DAC, those two are congruent. All right. So again, you got to really draw it so you can see it. What do you have? So what we have is we were told that these two are right angles. Okay. So I'm going to label that. I'm told that BAC and DAC, these two angles are congruent to one another. All right. So those are two facts. I need a third fact to be able to do this. All right. So what we hopefully you see is CA is common to both of these two triangles. They share this side, and this side's congruent to itself. So there's the third piece I need. So I got a right angle, a side, and a congruent angle, a right angle, a side, and a congruent angle. Now, if you look down here at the proof, this is something that's a little new to us. It's a new theorem. All right, and what this theorem says is that the reason that we can say two things are congruent is because all right angles are known to be congruent. So I got triangle ACB, which you were told is a right angle, and ACD is a right angle. And since they're both right angles, ACB and ACD have to be congruent to each other because all right angles are congruent. So there's one fact. BAC is congruent to DAC. That was a given. There's my second fact that I needed. The third piece of information is that AC is congruent to AC by the reflexive property. And therefore, the two triangles are congruent by angle, side, angle. Okay, so you just piece together your information. All right, they have to give you enough to get the problem. So you just need to look at it, write in what you have and what you're trying to get. All right, so now we move to the next ones here. They're asking you to write the proof yourself. Use again for the given information. We're trying to prove that DEF, this triangle on the right, is congruent to HGF, the triangle on the left. This is our given information. EF, this segment, is congruent to GF, that segment. Angle ED, angle EDF, which is this angle up here, and GHF, this angle up here, these two angles at the top, they're congruent. And from that, that's enough information for us to figure out the two triangles are congruent. So let's take a look. Let's label what we know. We know those two segments are congruent. We know those two angles are congruent. What else can we get out of the drawing? Well, hopefully you see these two vertical angles right here. All right. And that's enough. I'll have an angle, angle, side. Notice it's not the included side. It's just a different side. So it's angle, angle, side, angle, angle, side. Okay. So list what we know. EF congruent to GF. That was a given. Angle EDF is congruent to angle GHF. They gave us that. Angle DFE is congruent to angle HFG, vertical angles property. And that's the three pieces I needed. Since I have those entered in my proof, that's enough for me to say the triangles are congruent by angle, angle, side. Okay. All right. One more. So, here's the original triangle, and they're telling us that RTS is a right triangle, RTU is a right angle, right angle. SRT and angle URT are congruent. All right. So let's go ahead and enter that stuff in my drawing here. So I got, oops, this one's out of order. Sorry about that, guys. This was way out of order. Let me just put it all up here, then we'll go through it. Okay. So I went up here and labeled these two to be right angles. Then it gave me SRT and angle URT are congruent. That's these two angles. And then the two triangles we're trying to prove congruent share this common side, and it's congruent to itself. All right. So taking all that information down here, enter in my two givens that RTS and RTU are right angles. Therefore, those two are congruent to each other because all right angles are congruent. I need to make this statement. All right. I got to say that those two are congruent to be able to use those as a fact in my conclusion. Then I'm told that SRT and URT are congruent. That was a given. I got RT congruent to RT by reflexive. And now I know the triangles are congruent. That should be a triangle symbol there. Sorry. by angle, side, angle. Again, it's the included side between the two angles we know are congruent. All right. So those are the ones you're going to work on tonight. It's all angle, side, angle, and angle, angle, side. Okay. You're using, some of the things we already know, like vertical angles. A new concept is all right angles are congruent. So we're using, facts that we know and some new ones that we're learning, but it's all pretty apparent. And, most of the examples look just like the ones I gave you. All right. So watch the video. Um, now that you're done watching the video, I should say you're going to go to Alex, and then the Alex assignment follows very closely to the problem we just went over. All right. I'll let you have at it.